My name is Darren Thomas, and I'm the Director of Educational Research Techniques. This is Easier, Practical Applications of Machine Learning Algorithms in R. And we're now in Chapter 5, Lesson 2. And we've been looking at support vector machines and classification. And in this video, we're going to do our data preparation for making our models in Lessons 3 and 4, etc. So let's go ahead and move over to RStudio. So here's our code here in the upper left-hand corner. I'll give you a little bit more space so you can see things a little bit more clearly. So right here, there we go. All right, so in line 1 we have our code. So we're using 3 packages primarily. KernLab is the package that has the algorithm that we're going to use to make our actual models in a future lesson. The mass package is where our data came from, and the core plot is just for making a correlational matrix in this particular video. So I'm going to go ahead and run this first line. And now the data we're going to use is PIMA. You can always look up more about the data sets by, typing PIMA TR like so. And then if you look off to your right here, you can see the information. Let me zoom in for this for you so you can learn a little bit about this. So this is the diabetes in PIMA Indian women. So this data set has variables about women who have diabetes and women who do not have diabetes. And so there are 3 data sets. PIMA.tr means the training set, PIMA.te means test set, and if you want a validation set, you can use PIMA.tr2. So that's kind of what's happening. Now what I need to mention here before I explain more about the data sets is that this data is kind of already divided for you. This is unusual, but we're going to run with the training and test set that they already set up. We're not going to deal with the validation set so much. That is another style of doing data science and machine learning, but just to keep things simple, we're not going to deal with that. Now, back to this, you can see here we have the different variables here: pregnancies, glucose concentration, blood pressure, skin forceps, tricep skin thickness measurement, BMI, diabetes pedigree, age, and type. Now, type is going to be our dependent variable. Remember, we're doing classification, so it's going to be yes or no. And so this is all the information about our data set. I'm going to go ahead and zoom out now. All right, so that's explaining what's happening in lines 2 and 3. Now, all we're going to do now is we're going to take our PIMA.tr and put it inside a data set called training set, and our test set inside something called testing set. Because we've been doing that for several videos, and I just want to be consistent, and that's the main reason. Now, you can look at the data if you want, and you can see this is the same stuff I just told you about in line 8 of the code. You don't need this line right here. I forgot to delete this, excuse me. So in line 10, we're going to start taking a look at the visuals here, some histograms, just to get an idea of the characteristics of the data. Now, support vector machines is pretty flexible, but just for best practices, we're going to take a peek at it. So this is a histogram of a number of pregnancies. You can see it has I believe that's a Poisson distribution for count data. You can see that, of course, a lot of people have 0 to 1 kids, and it goes down like that. That's the characteristic of count data. And then, of course, this is glucose level, a little bit more of a normal shape there. Blood pressure looks pretty normal. Maybe some kurtosis problems there. This is the measurement of the skin. You can see someone was like really big, I guess, whatever. And then here's BMI. Looks pretty normally distributed, but you can always check it. PED, age, of course, more of a count data characteristic. And for a table, you can see over here down the bottom left-hand corner of the screen that we have 132 no's. They did not have diabetes, and 68 yeses. Now in line 20, what we're going to do now is that we're going to make the correlational matrix. Now we're using the core plot function, and inside the core plot function, we're using the core function, which gives us the correlations. We're excluding variable number 8. Now, if you look up here, you can see that there are 8 variables, and the 8th variable is a factor variable. Now, of course, I'm pretty sure by this point in your life in statistics, you know that a factor variable or a categorical variable cannot be in a correlational matrix because it's categorical, while correlational matrices deal with continuous data. So, having said all that, you can see the method set to numbers. I want to see numbers inside my plot, and I want all the color to be black. So if I do that, I get this nice little plot over here. That might be a little hard to see, so I will zoom in for you. So let's see here. It doesn't look like there's any problem with like very, very high correlations, but you want to be careful with BMI and skin. Well, that kind of makes sense. But generally, there's no high correlations here. Also, there's a correlation between age, and number of pregnancies, which again makes sense. As you get older, you probably have more pregnancies because you've had more chance to become pregnant. So again, we're just doing this for best practice. You need to be familiar with the characteristics of your data. Now, here's something that we need to do now. We need to scale our data. Support vector machines do better when the data is scaled. And if you're familiar with things like principal component analysis or factor analysis, you know that you want things scaled so that because the magnitude or how big the numbers are really affects how far and how close together they are. So you want to scale them for that purpose. And there's a lot of theoretical stuff here that I'm kind of glossing over to keep things simple. But what we have to do is this. We have to exclude our categorical data because we don't want to scale that. We don't want to scale that. And so what's happening is, if I had to give you a picture here, is that we have our data, so number of pregnancies or whatever, and glucose level, and then we have numbers here, numbers. But then we also have type, and type is yes, no, yes, whatever. And what we want to do is we want to remove this particular variable temporarily, just stash it somewhere while we scale these, and then we're going to put this column, this type variable, back into the data set. That's what we're going to do right now. So let me go back to RStudio. And so we're going to start by making something called keep, and we're going to store the type, that variable type there. That's what we're going to store and keep. We're going to do the same thing for the test set. Okay. Now in our training set, we're going to delete type and delete type in the testing set as well. We're removing it now because, like I just told you, we don't want to scale that. Now we're going to scale our data in lines 30 and 31, but we've already removed type because we did it in lines 26 and 27. Matter of fact, just so you know, let me just do str here, training set, and you can see that type is not available. It's all gone because we don't want to scale that. We put all NAs there. Now, we're going to create a data set called training scaled. And what we're going to do here is we're going to scale the training set and create this object that I just talked about and do it for the test as well. And now we're going to do the same. What we're going to do now is we're going to take what we put inside the keep. Remember we made something called keep way up here, right here in lines 23, 24, and we're going to add that to our training scale data in the variable called type. That's what we have right here. So I'm going to go ahead and do this. And now everything should be nice and ready. So you can see here that the numbers are different from before. Let me see here. So you can see here in training set, you can see we had glucose 86, 195, 77. Now glucose is like negative 1.19, 2.24. These are all z-scores for those of you who are more familiar with statistics. And so now we have all things set up the way we need them to be. Everything is scaled properly, and we're ready to go. So you can see there was every data set, and what you have to do is different. And so our data preparation in this particular example was a little bit more challenging. However, the only way to learn how to do this is basically through experience. Over and over and over, dealing with different types of data in different situations, you learn, you get a sense, you get this intuition about what you need to do. I've looked very diligently about trying to find like basic things you always have to do with data, and I've always really struggled with that because the context really determines the tools that you need to use for that situation. So the only way to get comfortable with data preparation is just to prepare a lot of data. So I hope that this made sense for you. My name is Darren Thomas. I am the Director of Educational Research Techniques. This is Easier, Practical Applications of Machine Learning Algorithms in R. Take care.